So today we'll be doing photoelectric effect. Photoelectric effect. The word itself explains itself. The word photo means light, and then electricity is a movement of electrons. So we are going to investigate the effect of it. It is as simple as that. So photo means, this photoelectric effect means electricity from light. We usually call it from the solar panels, the solar system actually. So let's explain this entirely. Photoelectric effect is what? Photoelectric effect is an emission. Is an emission of electrons from a metal surface. What do we mean by from a metal surface? When light, when light, because we are speaking of photo, so light must be there. When light is shown on it. Yeah. So in essence, when you light a metal, then you get to have electrons. It's more like when you sit on a streamline. Have you ever sat on a streamline on a very sunny day? You will feel there's too much heat on it. So basically what happens is electrons move from a metal surface to what we call an excited state. We won't be discussing the excited state for now. So for now we'll be discussing the general effect of photoelectric effect. So when you light a metal, you get to have electrons to move from the ground state to the excited state. Then from there you can store your electrons, right? Like what? Yeah, it's like your solar. Let's say you have a solar panel here. This is your solar panel. With this solar panel of yours, you shine light on it. When you shine light on it, what happens is electrons get to be emitted. So these electrons, you can store them somewhere, maybe in a battery. After storing them in a battery, then you can utilize your battery at any time. So that's photoelectric effect in a more general sense. So photoelectric effect, when you shine light on a metal surface, you get to have particles. These particles of ours is what we call photons. So photons are as simple as energy packages. That's photons. So photons are energy packages. So we have photons, which are energy packages. So if we have all of this energy, we can calculate energy from light. Light has energy, so we can calculate energy. When we calculate energy, what do we do? And here we have E is equals to HF. Energy of a photon is equals to Planck's constant multiplied by frequency. This means E is energy of a photon. Then H, a proper H, not this thing. So H is Planck's constant. It's Planck's constant. Planck's constant, because it's a constant, you can find it in a formula sheet. You don't have to stress yourself about it. It will be given in a formula sheet. Where we have constants, you will have Planck's constant. Then the last part is F, which is frequency. So frequency is measured in hertz. It's measured in hertz, which we symbolize by capital letter H. Then energy, energy we measure it with joules. It is as simple as that. So if you want to calculate energy of a photon that can emit an electron from a metal surface, you use energy of a photon is equals to Planck's constant multiplied by that h. So we said energy of a photon is equals to hf, which is Planck's constant multiplied by frequency. So remember that speed of light is equal to kappa speed is equal to frequency multiplied by wavelength. So if we are given a wavelength, not a frequency, instead of a frequency, what do? We then say we have frequency is equals to c over lambda. That is speed of light over wavelength. So we can substitute, where we see frequency, we can substitute this entire thing. So we can substitute frequency here. That means our E will be equal to Planck's constant multiplied by speed of light all over wavelength. So we know. So what do we have? We know E is equal to energy of a photon, that is measured in joules. Then this is Planck's constant that we find in the formula sheet. Then C is also a constant. Speed of light is also a constant. It's speed of light. Speed of light is equal to how much? It's equal to 3 exponent 8 meters per second. That is speed of light. Then lambda is wavelength. It's wavelength that is measured in meters. We measure it in meters and we symbolize it by symbol M. So in essence, we have everything that we need for now to calculate energy of a photon. If we are given wavelength, we can use this formula for wavelength. We can use this one if we are given wavelength. But if we are given frequency, then we can use this one. Or what we can do is, if you are given wavelength, you can try to calculate frequency using this formula, and then you substitute here the frequency that you get. You can then substitute it here. You'll be fine if you want to use that. That's what we have. The last part. Okay, not that much, particularly the last part. We have colors of the sky. We explain why the sky is blue. We have the colors of the sky. Rainbow, the rainbow that we see every day, consists of these colors, which is one is red, the second one is orange, same as this whiteboard marker. It's orange, then from there we have yellow. We have yellow, orange, yellow, and then we have green. After green, we have blue, then indigo. Indigo is a bit more the same as violet light. Then the last color that we will have is violet. So basically what we have here is rouge vif. So these are colors of a rainbow. I think we all know the rainbow. But if you were to look at it more closely, you will see how it consists of these colors. It's a rainbow, the rainbow nation of Tata, Nelson Mandela. What is happening here with these colors? With these colors, when we move from red and we go to a violet light, we are increasing. It's an increase in what? In frequency. That's if we move in this direction. But if we to move from this direction, from violet to red light, so in that direction, it's an increase in wavelength. So what does it mean? It means red has a low frequency but a higher wavelength than orange and other colors. I said red has a high frequency, a high wavelength and a low frequency. So that means orange has higher frequency than red, but lower wavelength than than red, yes. So orange has higher frequency than red, but lower wavelength than red. So that means even with yellow, it's the same thing. With yellow, yellow has high frequency, but low wavelength than both orange and yellow. So it means yellow light, the frequency of yellow light is a bit stronger than this one of orange and red, but the wavelength of it is way lower than orange and red. It does the same thing applies with green. So green has what? Green has high frequency than yellow, orange, and red, but low wavelength than yellow, orange, and red. Now this part is the part that explains why the sky is blue. The sky is blue not because it's a reflection of water. It's not a reflection of water because water is colorless, right? So if the sky is blue, what makes the sky blue? The colors of the sky are these ones. It's red, orange, yellow, green, blue, and indigo and violet light. These are the colors of the sky. But the reason why we see the sky as blue is because the particles of the blue light can interact with the sky easily more than that one of green, yellow, orange, and red. Why? Because red, orange, yellow, and green have high wavelength yet a low frequency. That means what? That means indigo and violet light have the very strongest frequency, but the very lowest wavelength. So that the particles cannot interact with the sky. But this one's, it's moderate. The frequency and the wavelength of the blue light are moderate. Hence, its particles get to be able to interact with the sky. Hence, we see the sky as a blue light. Right? Okay. Then the last three parts. Let's do what we call the threshold. Yes, it's threshold frequency. So the threshold frequency, what we symbolize it with F naught. Say it's F naught. That's threshold frequency. Threshold frequency is what? Threshold frequency is the minimum what? Minimum frequency. So it's threshold frequency. It's the minimum frequency needed. We need to emit electrons. From what? We emit electrons from the metal surface. So for us to, in order to know if electrons are emitted or not, we will then check the threshold frequency of ours. So the threshold frequency is how much? Threshold frequency, because the frequency we measure it with hertz, and the symbol is capital letter H. Then we have work function. So work function. Explanation is a bit more the same. Work function, we symbolize it with capital letter W and then naught. It's W naught. So W naught of ours means it's work function. So work function is the minimum energy. The very same way as frequency is the minimum, or threshold frequency is the minimum. Even this one is the minimum energy. Here is the minimum energy needed. And needed to what? We needed to emit electrons from the metal. Surface. That's the work function. So we have threshold frequency. The threshold frequency is the minimum frequency, I meant to say. That is the minimum frequency that is needed to emit electrons from the metal surface, the same way as the work function as the minimum energy that we need to emit electrons from the metal surface. So, what do we know? We know that this is energy of a photon. Energy of a photon. So for energy of a photon, what do? We say energy of a photon is equal to work function plus kinetic energy maximum. We know. What do we know? We know that energy of a photon is equal to E, or E, not is equal to E. We know that E, which is energy of a photon, is equal to HF, and then work function, our work function is equal to Planck's constant multiplied by threshold frequency plus kinetic energy is half mv squared, but this half mv squared, ours is maximum. So what do we mean? We mean Planck's constant, we said it's a constant, you can find it in the formula sheet. Frequency, we know how to calculate frequency. We can use, if we're not given frequency, then we know speed of light is equal to frequency multiplied by lambda. So if this is the case, then frequency, it can be equal to lambda c over lambda. So we can use this formula to find frequency. And then from there, we will have Planck's constant. Planck's constant is the same thing. You get it in the formula sheet. Threshold frequency will be provided with threshold frequency, the minimum energy needed, or they can say to you calculate the threshold frequency. So you can calculate the threshold frequency to see if the electrons will be emitted from the metal surface. Then from there, we have mass. Here we will substitute the mass of an electron. Mass of an electron is a constant also. Mass of an electron, you can find it in the formula sheet. It's 1.6 exponent minus 19. Then maybe you'll be provided with the velocity of the electron. So in essence, this is photoelectric effect. This is how we get to have what? This is how we get to have electricity from light. It is not difficult. It is one of the most simplest of them all concept in physical sciences, grade 12.